So one place where Adj-R-squared is going to be really useful is when we're choosing between non-nested models. So I'll explain what non-nested models are in a second. Choosing between non-nested models. So this is when we when we can use adjusted R-squared. So we can use adjusted R-squared to help choose between these non-nested models. And it's going to be particularly ones with different functional forms. Functional forms. So now let's make sure we understand what non-nested models are. Non-nested models are, two models where one of the models is not a special case of another. So non-nested models are models where one regression is not a special case of the other. And so, for instance, let's write out two different non-nested models. Well, let's write three models out. Two that are nested, one that's not nested. So let's write out regression one. So let's say our y variable equals beta 0 plus beta 1 times the log of sales plus beta 2 times some variable called pay plus u. Let's say that's model 1. And let's say model 2 is y equals beta 0 plus beta 1 log sales plus epsilon, some different error term. And let's say model 3 is y equals beta 0 plus beta 1 sales plus beta 2 sales squared, so a quadratic in sales, plus some error term, plus u. U tilde, whatever you want to call this. So these number 1 and number 2, these first two models are nested, right? Like we could choose between these models by just testing the parameter on this extra independent variable. We can see if it equals 0 or not, and to know whether we should include it in our model. But, models 2 and 3 and 1 and 3 are non-nested, right? In the first and second models, we're capturing this non-linearity of this relationship between sales and y through this log. How we're capturing this non-linear relationship between sales and y in this third regression, this third model, is through this quadratic. So these are non-nested because this third regression is not a special case of either of these first two, because we have a completely different functional form in our independent variable of interest here. So let's maybe write out that 2 and 3 so is 1 and 3 as well, are non-nested. So 2 is not a special case of 3. We're just capturing this relationship between sales and y in a different way than in regression 3, which is through this quadratic. It's hard to use R-squared to choose between these two models. So we can't use R-squared. choose between the models, because that doesn't seem fair, right? Because like this third regression has two independent variables. This one only has one. We kind of learn that as we add more variables, it's kind of naturally going to increase the R-squared. So instead what we're going to use is we're going to use the adjusted R-squared. So we're going to use the adjusted R-squared to choose which model we prefer. So we just estimate both of, let's say, in this case 2 and 3, we could do 1 and 3 as well, and figure out the adjusted R-squared, which has a greater adjusted R-squared, and that's the model we should use. And so this allows, this helps us to figure out which functional form we should be using in our regression.